Let's go ahead and get started with Unit 11. The I can statement today is I can understand and perform translations and reflections. So let's write the word reflections here. So reflections. And these are probably things that you've heard of before. You've maybe done these in a previous class, but let's make sure that we do this warm-up right here. There's some important things here. It says graph and label each equation. So we want to graph the line y equals x. So remember, that's got a y-intercept of 0 and a slope of 1. So that is that perfect 45 right through the origin. Goes like this. So I'll just draw that as nice and straight as I can. And then we'll label this. Again, we put arrows on the ends, and then we're going to label this as y equals x. And then I'm going to change colors and come back here and do y equals negative x. Remember, that's the same line. It's just been vertically flipped. It's been, instead of a perfect 45 going straight up, we're going to go down from left to right. So it's going to look like this. Okay, so I'll just go ahead and draw that line right there, making sure I hit some of those key points there. Draw an arrow on each end, and then we're going to write y equals negative x. And then we're going to draw the line y equals 0. Well, y equals a number is a horizontal line, so it crosses the y-axis at 0, and it also has a slope of 0. Okay, so horizontal line right here. In fact, y equals 0 is another way of talking about the x-axis, which seems kind of weird that you use the y-coordinate, the y variable, to define what the x-axis is, but that's the way it works here. And x equals 0. Remember, x equals a number is a vertical line, so we're going to make this go right here, okay? The x-coordinate of every single point on the y-axis is 0 because you don't go right or left. You can just go as far up or as far down as you want. So I'm going to label that one as x equals 0. All right, now, when we're talking about transformations of figures on the plane, they're a little different than the transformations that we worked with functions and equations. Remember that when we worked with transformations of functions, we had to be concerned with when the change took place, so that they add or subtract before or after the function made the shape. So if we made the change before the function made the shape, that was a horizontal change, and if it made it after it made the shape, then that was a vertical change. Now, I'm going to come back here and I'm going to put a little asterisk by horizontal, because when we were dealing with functions, it did the opposite of what you'd think. And this is one of the major differences with transformations of figures. All of the things that we talk about in terms of the x direction and the y direction, they are going to do exactly what we think. And that's the major difference between transforming functions and transforming figures. So transforming figures is more straightforward, but we're still going to need to be careful with the details. The 4 transformations are this. So let's write down translations, reflections, and then the last one is dilations. The third one is rotations. So we're going to put rotations in here. All right, and we're going to look at some vocabulary reminders. So it says rigid. Rigid keeps the figures the same size and the same shape. Same size and the same shape. So it doesn't really change anything. It might just move it around or flip it over or something like that. And that brings us to the next word. Congruent is the geometry word for equal. So equal is the word we use to refer to numbers. If we're talking about shapes that are exactly the same, then we use the word congruent. And when we say they're congruent, what we mean is they're literally the same size and the same shape. Now, we do need some notation, and you might remember this. So we use prime notation. Prime means new. Prime is the word that means new, and the notation looks like this. So if we were to have an old point P, and then we were to transform that and make a new point P, this would be P prime. And it's possible to do more than one transformation. So if we do several in a row, which are called composite transformations, we might have a P, which is the original one, the old one, and then a P prime, which is the new one, and then a P double prime, which is the next new one, and then a P triple prime, and so forth. But we'll worry about that when we get there. And then it says similar. So similar figures have the same shape, but different size. So let's write different here. So they're very similar in shape, but they're different in size. One's bigger, one's smaller, so we could use the word stretched and shrunk there. And then orientation refers to which direction the figure is pointed. It might be flipped over, it might be turned a little bit, so it's pointed a different direction. And then the pre-image is the word for the old figure, so that's like the original one. And then the image is the word for the new figure. And then the last thing I want to talk about right here is the line of symmetry. We're going to mention that a whole bunch when we talk about reflections, which we'll do today. So the mirror image, the line of symmetry is the mirror line for those reflections. Okay, so let's come down here and let's talk about translations. Translations, if we used a shortcut word here, kind of a little more informal word, we'd say those are slides. So when we translate something, then we're going to slide it left, right, up, or down. So if we slide it left or right h units, what we're going to do is we're going to take the x coordinate and we're either going to add or subtract h. And again, this is one of those differences. This does exactly what you think. If we add something to x, we're going to move it to the right. If we subtract something from x, we're going to move it to the left. And then up or down works the same way. So we're going to shift up or down. If it's going to be up if it's positive, down if it's negative. K units. So we use a slightly different letter here. So we use h with the x's and y with the, or k with the y's. And we can do more than one transformation at one time. So we could do something like this. We could have x plus or minus h and then y plus or minus k. It would be possible to do something like that. So let's take a look at this quick little example here. It says, be sure to keep straight which is the pre-image and which is the image. And then we want to write a mapping rule. Now, you're going to hear me say this a couple of times. This is the old one. So I'm actually going to write the word old next to this. So that we can tell. So this is the old one and this is the new one. And the reason we want that is we want to know which direction it moved, because there's a difference between moving back and up to get to this new L versus moving down and right. So a common mistake is mixing up which is which. So in order to do this, in order to go from L to L prime, this is the old one, this is the new one, we went back 1, 2, 3, 4 spaces, and then we went up 1. So we're going to take the x and we're going to subtract 4 from it, and we're going to take the y and we're going to add 1 to it. And you'll notice that that same rule works for these other points. That's why this new figure, the one with the primes on it, looks exactly the same. It's still a congruent figure with the original image. So pre-image, I apologize. So if we were to take f and we went 1, 2, 3, 4 to the left and we went up 1, we get to f prime. All right, so let's take a look at reflections. Reflections are, as we said before, they are a mirror image across a line of symmetry. So if the line of symmetry is the line y equals x, which is why we talked about these earlier, then all we have to do is we just have to switch the x and y coordinates. I mean, literally that's it. We just switch the x and y coordinates. If we reflected across the line y equals negative x, we switch the x and y coordinates, but we also make them the opposite sign of what they used to be. All right, so if the old y coordinate used to be positive, it's now negative. If the old y coordinate used to be negative, then it would be now positive. And we'll take a look at a couple of examples here. And then across the y-axis, all we have to do here is change the sign of the x coordinate. You'll notice that the y stays in the same place, and it's exactly the same. The x stays in the same place, but it's now a negative. It's the opposite of what it used to be. And you might be able to use that to figure out what goes on here. So if we were reflecting across the y-axis, so if the y-axis was our line of symmetry right here, we change the sign of the x coordinate, and we can use the same thing to figure out what goes on here. These are going to stay in the same place. There's still going to be x's and y's, but think about this. If we reflect across the y-axis, the x-coordinate changes sign. If we reflect across the x-axis, it's going to be the y-coordinate that changes sign. So let's go ahead and take a look at this one right here. It says, write a mapping rule, and then it says, always draw the line of symmetry. So if we take a look at this right here, you can see that these two they're very closely related. And one thing you can do is kind of tilt your head around until you see that there are reflections across a line. And I'm going to go through this a little bit backwards. I'm going to draw the line of symmetry. Let's take a guess that it's the x-axis. Well, if the x-axis is the line of symmetry, then the bottom would look like the top. And that's not the case here, so that's not it. If it were the y-axis, the right side would look like the left side and vice versa. That's not the case here. If it were the line y equals negative x, okay, so we know what that looks like, then this side of the line would look like that side of the line, and that's not the case. I mean, these are not mirror images across that line right there. But if we draw the line y equals x, so I'm going to go ahead and do that, and I'm going to do this in a dotted line here just so we don't get confused here. So this is going to be y equals x. If you tilt your head a little bit to the side, you can kind of see that, hey, yeah, if I go straight through this line, kind of at a perpendicular angle, I go right over here and I get to b prime. So if I go from G, I go straight over here, I get to G prime. Notice that they're both the same distance away from that line of symmetry. So this is kind of like our fold line or our mirrored line right here. So in order to write down what the formula is for that, what the mapping rule is for that, it's going to take a while to get these memorized, but remember, this is probably the easiest one that we've got as far as reflections go. If it's a reflection across the line of y equals x, we literally just switch the x and y. So we're going to do y here and we're going to do x there. Now, just to double check and make sure that this actually works, let's take this point right here, which is 2, -1. And literally what this says we're supposed to do is on the new one, we would switch the x and the y. So this should be, at b prime, it should be -1, 2. So let's check and see if that actually works out. -1 and then up 2, it does work. Okay, so we're in good shape there. So now what we want to do is we want to practice using these. So it says graph the image of the figure using the transformation given. Use proper notation for the image. Now when they say proper notation for the image, what they're talking about is prime notation. They're talking about using that right there. Okay, so don't get this confused. The one that's originally there, that is the pre-image. That's the old one. And then the one that we're going to make through the transformation, that's called the image. So we're going to take this and it says translation. So remember, a translation is a slide. So we're going to take this and we're going to slide it 3 units to the right and down 4 units. So we're going to go 1, 2, 3. So remember, to count spaces, don't count dots. Don't start counting 1, 2, 3. We're going to go 1, 2, 3, and then we're going to go down 4 units. 1, 2, 3, 4. So I'm going to put a dot right there, and I'm going to label that as A prime. Then we're going to go right 3. So we're going to go 1, 2, 3, and then down 4. 1, 2, 3, 4. So we're going to put a dot right there. That's going to be B prime. That's proper notation. And then same thing here. 1, 2, 3 to the right, and then down 1, 2, 3, 4 right here. And we're going to put that down as C prime. And then as carefully as you can, let's make a nice straight line for each one of these. So notice that this new one, the image, is just like the pre-image. We've just slid it around. Okay, so on this one, they didn't give us a phrase to describe this, a verbal description. They gave us a mapping rule. So remember, if we take x and we subtract 2, that's going to do exactly what we think this time. Okay, so this is going to be to the left 2. So I'm going to write left 2. And then y plus 3, this is going to be up 3. So we're going to take this and we're going to go back 2. So the left 2 and then up 1, 2, 3. So here is the A prime. And then back 2 and up 3. So here's the B prime. Oops, let me make that look like a B. And then back 2 and up 3. So we're right here. So we've got a C prime. So let's go ahead and draw those. Doesn't have to be perfect. You can see what went on here. You can see that this is the image and this is the pre-image. And it does look like we went left 2 and up 3. So translations are kind of like sliding a placemat around on a table. Now, what I'd like you to take a look at is, do you notice any similarities between the image and the pre-image? Do you notice any similarities between the two of these? So orientation, size, shape, and congruent. Well, orientation-wise, notice they're pointed the same direction, okay? So we're going to put same right here. Size-wise, definitely the same. And shape-wise, yeah, so these are all the same. Okay, but let's talk about congruent. Are these two figures congruent? So is the image, or the pre-image here, and the image, are they congruent? Are they the same size and shape? Well, we kind of already answered that. So this is going to be a big fat yes right here. They're actually congruent. So taking these and sliding these around the plane doesn't change the size or shape, so they're definitely congruent. So we're going to flip the page over and take a look at the next one. Okay, so on example 2, it says graph the image of the figure using the description or transformation given and use proper notation. So again, that's that prime notation. So let's reflect this across the x-axis. And remember, it's always a good idea to draw the line of symmetry. So let's write the word symmetry right here. So the line of symmetry on this one is the x-axis. So this is our mirror line. So I'm going to go ahead and draw that right here. And then what we're going to do is we're going to reflect it across there. So probably the easiest way to do this, at least visually, is to do this. We could go back and look at the rules, but I want to see if we can figure out why those rules work the way they do. So what we're going to do is we're going to take this point right here and we're going to reflect it across. Now notice that it is 1 unit away, straight up above the line. So what I'm going to do is I'm going to move this so that it's 1 unit straight down below the line. So I'm going to mark that as a B prime. Do the same thing here. I'm going to take A and let's count 1, 2, 3, 4 spaces away from the line, above the line. So let's go 1, 2, 3, 4 spaces below the line. So this is going to be A prime right here. 2 above, we're going to trade that for 2 below, and then we're going to go ahead and draw that line right there between each one of the points so we get the figure. Now, if you were to tilt your head to the side so that you could line up here, that would be okay. But you can also see that the top is exactly the same as the bottom. It's just been flipped over. Okay, so let's come over here to the mapping rule. The mapping rule says we're going to switch the y for the x. So I'm going to do this a couple different ways. You may remember what happens here. So I'm going to take the a and I'm going to list what coordinates a are. So the coordinates for a are -2, 4. So -2, 4. And the coordinates for b are -1, 1. And the coordinates for c are -5, 2. So -5, 2. Now what I'm going to do here is I'm going to figure out what each one of these new ones is. So all I have to do is I just have to switch the x and the y. So this is going to be 4, -2. This is going to be 1, -1. And this is going to be 2, -5. So what I'm going to graph here are each one of these prime coordinates, each one of the new ones. So let's come over here and graph those. So a prime is going to be 4, -2, over 4 and down 2. So this is going to be A prime. And B prime is going to be 1, -1, so over 1 and down 1. So there's B prime. And then C prime is going to be 2, -5, so over 2 and down 5. So that's going to be right here. So there's C prime. And then we'll go ahead and connect those. Okay. Now, you may have recognized, because we did one of these already, you can, it does ask us to draw the line of symmetry here. So the line of symmetry would be right here. It's going to be that perfect 45 right through the origin. It's going to be the line y equals x. Okay, so if we tilt our head to the right about 45 degrees, so you can go ahead and do that, if you kind of line this up, then this side would look exactly like that side. You can kind of see the mirror image, so it's a reflection across the line y equals x. Now what I'd like you to do here is note some similarities between the pre-image and the image. Again, what do you notice about the orientation, the size, and the shape, and what about congruency? So on this one right here, they're definitely not oriented the same. I mean, at first glance, they kind of look like they're totally different triangles and they don't have anything to do with each other. So I'm going to write different here. Okay, they're oriented differently. And that's the same thing with this one right here. As far as the size goes, they're each the same size. So I'm going to put same here. And then as far as the shape goes, well, the shape is still the same. It's just flipped over. So this one was this triangle up here. We flipped it over down here. It's not like they're different triangles. They're still the same size and they're still the same shape. So on this one, yes, definitely they are still congruent. Even though they're oriented differently, the point here is they're congruent as long as they have the same size and the same shape. So this next one, it says, write a mapping rule and a verbal description for each transformation. So let's come down here and let's see what we've got on this one. So the good news on this is it's already given for us. The image and the pre-image, again, this is the pre-image and this is the image. Image means new one, remember. Okay, pre-image was the one before. So we want to write a mapping rule and a verbal description. Well, sometimes it's easier to write a verbal description first. So here's what I'm going to do. I'm going to look at this, and you can kind of tell just by looking at this straight on. These are mirror images of each other. Okay, so if this is, like we said here, if this is the old one and this one here is the new one, okay, we can kind of keep straight. This one got flipped over here, this one got flipped over here, and that one got flipped over here. So what we have is a reflection across the y-axis. So reflection across y-axis, okay? And then the rule for that, well, let's see if we can figure out what the rule is for this. So notice that the coordinate right here was 2, 1, and the coordinate for this one right here was -2, 1, and this one might ring a bell. Remember, the only thing that changes when we reflect it across the y-axis is the x-coordinate changes sign. So this is going to be -x, y, and you could check these other two and it's going to work the same way. All right, let's do the same thing here. Again, this one looks a little bit different. This is actually easier than this last one, but it would be a really good idea. Again, we're going to do old next to this one. Whoops, old next to this one. And then we're going to do new next to this one. We've got to do that in order to get the directions straight. So what happened here is this is the old L and this is the new L. So they must have taken this and slid it back 4 units and up 2. So let's say left 4 and then up to, and that of course is a translation. So lots of different ways that you could write that and make sure that that's correct. Let's write down the rule for this. The rule for this, if you want to go left 2, you're going to take the x's and you're going to subtract 4. And if you want to go up 2, you're going to take the y's and you're going to add 2. Okay, now let's come down here and let's talk about the last little bit here. It says one of the biggest advantages of rigid transformations, and remember, rigid means they don't change the size or the shape. They might change the orientation, but they don't change the size or the shape. They allow us to slide, reflect, rotate figures, and still maintain congruency. And this is going to be a really big deal for the next little bit, okay, for this unit and the next one. So when we say congruent, remember what that means is, it just means it keeps it the same size and the same shape. So when figures are congruent, the angles and the sides on the pre-image are congruent to corresponding angles and sides on the image. Okay? Now, on example 3 up above here, let's come back up here like it says in this box right here. It says, please list 2 of the corresponding sides or angles in example 3 above and use proper notation. Now, I don't really care which one we look at, but let's just look at this one because this one was done last, and it's a little bit easier to kind of organize. What I'd say right here, maybe for an angle statement, is I would say that angle L is congruent. Remember, that's the symbol for congruent, is congruent to angle L prime. And over here, we might say something like, hey, you know this side right here from M to N? It's exactly the same length as this side right here from M to N. So we're going to go MN, and again, we make it look like that, is congruent to M prime, N prime, like that. Now, if you wanted to say a couple of these for each one of them, I mean, you could come through here and you could say that line or side LB or LE is congruent to L prime E prime or something like that. That's kind of what we're after as far as using proper notation and just mentioning and realizing that those corresponding sides and angles are still congruent on the pre-image as included with the image. Okay, so let's come down here and take a look at the end of this. It says, draw the line of symmetry and perform the transformation, or give a verbal description. So when it says reflect across the line x equals 2, well, we've got to do the work here. So let's draw the line x equals 2. The line x equals 2 would look like this. Okay, so there's the line x equals 2, and I'm going to go ahead and label that. And then I'm going to switch colors so that I can reflect this. So here's how this reflection would work. I need to make a mirror image across this vertical line. So that means I'm going to take anything that's on the right and put it on the left, and anything on the left, I'm going to put it on the right. So if this is 1 unit over on the right, I'm going to make it 1 unit over on the left. So there's going to be H prime. If this is 2 units over on the left, I'm going to make it 2 units over on the right. So that's going to be G prime. And again, this one is also 2 units to the left, so I'm going to make it 2 units to the right, and I'm going to call that F prime. And there we go. Now, my drawing is not perfect, but you can kind of see, just kind of staring down that middle line right there, everything on the left was switched over here, and they do look like they're mirror images of each other. Okay. Now, on this next one, it says give a description. So luckily, we don't have to come up with a mapping rule for this one, but let's identify where the line of symmetry would be on this. So the line of symmetry on this one is, it's kind of right where these intersect right there. So it's going to be this line right here. So that would be the line y equals -2. That's the line of symmetry. So this is a reflection across y equals -2. Okay. Now, we don't use reflections like this very often, but they can be useful. And we ought to note a couple of corresponding sides or angles in example 4b. So let's go ahead and take a look at this, and let's just make a little statement right here. Can you see that the size of this angle right here, angle E, is just the same as angle E prime? So one thing we could say is those two correspond to each other. So we could say angle E is congruent to angle E prime. And we could also say, by taking a look at this, now this one should be pretty easy. This is GQ, oh sorry, other way around, QG, I suppose. So QG, if we read it this way. So QG right here is congruent to this one right here. And you can see, you can actually count them off. You can figure out that they're both a length of 4. So we could say that QG is congruent to Q prime G prime. And then we'll put the little lines above those. So it's a good idea to just kind of keep in mind mentally that those are related to each other. Now, it would be a good idea that you memorize these rules. The translation rules are pretty easy. The whole left, right, up, down thing, that's pretty easy. The reflections across lines of symmetry, that's a little bit more difficult. But again, if you've got these understood as far as how they work, they're much, much easier. You really don't have to have them memorized. But I would get those committed to memory or have them figured out so that you know what they are really quickly. So for example, remember if we reflected across the y-axis, it was the x-coordinate that changed. If we reflect across the x-axis, it was the y-coordinate that changed sign. And then across the line y equals x, switch the x and y. And if it was a negative x, if we're reflecting across that line, we still switch them, but we also make them the opposite sign. Now, I think what would be really interesting is this little thought experiment right here. We know mapping rules for all of these other ones that we've worked on, but not for reflections across vertical lines like x equals 2 or horizontal lines like y equals -2. It might be interesting for you to think about what those would look like. You can come up with rules like that. They are much, much more complicated than that, and it might take some trial and error before you get it. If you're interested in that, you're welcome to come and talk to me, before or after class or something like that. So go ahead and do the self-assessment right there, and then go ahead and get started on the assignment.